All right, so now we are working on composite volume. And composite volume, pretty much, I guarantee that all of you are going to like more than composite surface area. Composite volume doesn't have to do with touchable surfaces. It just has to do with, like, if you were filling it with liquid or sand or some sort of substance, how much would be together in there. So when we have something like this composite, when something is stacked on top of each other, it doesn't matter if anything's overlapping. It doesn't matter if you can't touch one side of the box. All you're going to do is either add volumes together or subtract volumes. So I'm going to take this as two different shapes. I'm going to take my prism 1 and prism 2. I'm going to do a different color. Prism 2. So prism 1 and prism 2. So I'm going to take the volume of prism 1 plus the volume of prism 2, and that's going to give us our answer. So looking at prism 1, we're going to find the area of our base. It looks like we have a cube here. So the area of the base is going to be 8 times 8 times the height of our prism, which is 8, which, since this is a cube, just happens to give us 8 times 8 times 8, which is the same as saying 8 cubed, 8 to the power of 3, which is 512 cubic inches, or inches cubed. Then I'm going to look at the volume of prism 2. This also seems to be a cube. It's got side lengths of 12 and a height of 12. So 12 times 12 is the area of the base times the height, which is 12, which is the same thing as 12 cubed. 12 times 12 times 12 gives us 1,728 cubic inches. So now I take my two numbers, 512 plus 1,728, and the total volume of my shape is 2,240 inches cubed. It must be cubed. They are cubes, therefore they must be cubes, because we're dealing with volume. Just because we're dealing with volume. All right, now the other version of composite you might get is that if you're